Hey guys, happy Tuesday. Hopefully you all had a restful 3-day weekend. So again, we're gonna jump back into trigonometry here. So again, your sine, your cosine, your tangent. We're gonna be finding again missing side of a right triangle. But today again, we're gonna work with real world applications. So find the height of an object or how far away we are from a building, things like that. So again, you guys know the deal. Make sure you're following along, taking notes, doing the examples. So let's just jump right into it. And again, the idea is still the same, guys. You're still working with a 90-degree right triangle. But again, they're just modeling real world situations. And again, we have SOHCAHTOA, still sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Again, SOHCAHTOA is still there. Again, I would take a second. I'd write this on the top of your paper so you don't have to flip back and forth unless you've already committed it to memory. All right, but let's jump into example one now. Of course, you don't have to copy this entire story. The picture should be enough, and then just making sure you understand, hey, what did I actually find? Okay, because yes, you are going to be finding a sign, but what was it? The distance from an object, how high it was, the length of a rope, things like that. Make sure you understand at the end of it, hey, what did I actually truly solve for? Yes, I found that it was 8 meters or whatever it was, but what does it stand for? All right, so let me read you guys this. It says Archimedes went to sleep beside a big rock. So here we see this is this big rock right here. He wanted to get up at 8 a.m., but the alarm clock was yet to be invented. He decided to sleep at a spot where the rock's shadow should end when it's 8 a.m. so as to be awakened by the direct sunlight. So again, we see the sun. And again, it's going to cast a shadow, and eventually it'll wake him up at 8 a.m. Okay. So it says Archimedes knew that at 8 a.m. the sunlight reached the ground at an angle of 43 degrees. So here's the sun's little rays, that shadow, and it's giving him a degree, an angle here of 43. The rock beside which he slept was 7 meters tall. So again, here we have a rock, 7. I should actually label that with meters. So when you guys draw this in your notes, make sure you add M for meters. All right. Now it says, hey, what's the actual question? What am I trying to find? How far from the rock did Archimedes go to sleep? So again, he's posted over here. He's taking a nice little nap. I want to figure out the distance away from the rock. So I'm looking for this flat bottom piece. Let's label that with X. All right. And then you guys know the deal, right? We always want to kind of go through this and label opposite, adjacent, hypotenuse. So again, where should I be standing? Well, they gave me that my degrees was 43. This is going to be my reference angle, my theta. And completely opposite across of that is 7. So O, P, and P. For opposite, here's my 90 degrees. Across, always for 90 degrees, the longest side will always be the hypotenuse. And then lastly, my adjacent bottom piece here. Let's go ahead and label that. Now let's ask ourselves, right? What do they give us and what are we trying to find? Well, they gave us at the rock here, the opposite side is 7 meters. And what am I trying to find? My adjacent side. Okay. So again, going back to SOHCAHTOA, right? SOHCAHTOA. Let me write that up here. Which of these is it going to be? Which one is talking about opposites and adjacents? That's going to be tangent. And again, we know tangent. Whoa, let me go back here. I know that tangent of theta is equal to my opposite over my adjacent. Well, let's go ahead and figure that out. Let's set up our problem here. So let's go ahead and put tangent. How many degrees do we have here? We were standing at 43 degrees. Is equal to, what's my opposite side? It's 7 meters. So I'll put 7 over my adjacent, which is x, which is what I'm trying to find. Now, my whole purpose here is to solve for x. So let's multiply both sides. Whatever I do to one side, I do to the other. So times x, cancels. I bring down x times tangent of 43 degrees is equal to 7. Now I still have that tangent of 43. That is with my x. So how do I get rid of that? We're going to go ahead and divide both sides by tangent 43 degrees and this side also by tangent 43 degrees. Cancel those guys out. I get x is equal to 7 divided by tangent of 43 degrees. So actually, let me take out my calculator here. I'm going to put 7. I'm going to divide that by 43. I'm going to hit the tangent key. And I'm going to hit equals one more time. And I get that it was 7.5 and then 0.6. All right, so I'm going to stick with 7.5. Now again, what did that represent? What were we trying to find? The distance away from the rock. So this entire distance down here where x was, that measures what? 7.5 meters. All right, guys. So next example here, it says a tower casts a shadow that is 60 feet long when the angle of elevation of the sun is 65 degrees. How tall is the tower? Okay, so I want you guys to take a second, try to draw this on you out, and when you're ready, hit play. All right, so again, the hardest part is honestly just, hey, what's the picture that I'm working with, right? So it says a tower casts. So here's my tower, same thing, right? It doesn't have to be anything fancy. There's the tower. And it's saying that it casts a shadow. So again, imagine that your sun was out here just like in the last problem. Okay, and it's casting a shadow. All right, so this is the shadow down here. The sun's over there. My shadow is going to be on the floor. All right. And the shadow that is 60 feet long. So this bottom piece where the shadow is on the floor, that is going to be 60 feet. Okay. And then it's asking when the angle of elevation of the sun is 65 degrees. So again, that angle that it's creating, right, all the way up to that sun, it's 65 degrees. And again, notice inside here I have my nice right triangle. It's saying how tall is that tower? I want to figure out this piece on the right over here. How tall is my tower? All right. So let's go ahead and do this, right? So where should I be standing? Okay. 65 degrees. If I go directly across, that is my opposite side. So this time I'm looking for opposite. And then 60 feet here is going to be my adjacent side. And across the 90-degree angle, that's my hypotenuse. Okay? So what do they give us? What are we trying to find? Okay, they gave us that my adjacent side was 60 feet, and I'm trying to find the opposite, which is the height of the tower. Okay, so okay, so which one has opposite and adjacent? Same thing, it's going to be tangent, but this time it's going to be slightly different. Tangent theta is opposite over adjacent. Well, let's set this problem up. Okay, so we're going to say tangent of, where we be standing, where's my reference angle? 65 degrees is equal to my opposite side, which I didn't know, which was x in this case, over my adjacent, which is 60 feet. All right, I got to solve this guy here. How do I get rid of dividing by 60? Well, I multiply by 60. Whatever we do to one side, we do to the other. The 60 is on the right, canceled out, and I'm left with 60 times tangent of 65 degrees is equal to x. Now, x is all by itself. All I have to do is hopefully correctly plug this into the calculator. And again, if you're an Android, lucky you, you can plug it in as you see it. For me, I'm going to go with 60 times 65, and I hit the tangent key, hit it one more time. All right, and I get it's equal to 128.67 is equal to x. Now again, what did we just find? What does this actually stand for? Before it was just an actual number. So it's 128.67 units was feet. But this here is representing how tall the tower is. Again, how tall, it was my opposite side. How tall is the tower? 128.67 feet. All right, next one here, let's go. Okay, so this one's going to be slightly awkward. Take a second, copy that picture, and we'll go through it. Okay, so they're asking us to find the value of x, but this time's a little weird, right? It's like x plus 1. Normally I just had an x, but let's see what we can do with it. All right, so again, whoa, what just happened there? All right, let me put SOHCAHTOA up there. Okay, here we go. Now again, let's go ahead and label this as theta. Directly across is my opposite side. Across the 90 degrees, that's my hypotenuse. And of course, the last one here is going to be my adjacent. Okay, so how can I solve here for x? Well, I know my hypotenuse is 10. I know my opposite is x plus 1. So what has opposite and hypotenuse? that is going to be sine. So we're going to say sine theta, which is opposite over hypotenuse. How would we set this up? How can I set this up? Well, let's go ahead and put sine of 45 degrees is equal to my opposite side, which was x plus 1 over my hypotenuse, which is just 10. Okay, same thing. How do we get rid of that 10 on the bottom? Well, I still have to multiply by 10. Multiply by 10. The 10s will cancel out. And now I get 10 times sine of 45 is equal to x plus 1. Now, normally I would just be ready, right? But I still have that plus 1 that's sitting out in front. It's kind of like a multi-step equation. Okay? So how would I get rid of the plus 1? Well, I'm actually going to have to subtract the 1. Whatever I do to one side, I have to do to the other. But it's like, what the heck? Do you subtract the 1 from the 45, from the 10? Well, what we actually have to do is we're going to have to work this part out first. We're going to do 10 times sine of 45 degrees, just like we normally do. Okay, whatever we get after that, at the very end, we're going to have to subtract 1 from our answer to get the value of x. So I'm going to plug in. Let's see, here we go. 10 times sine of 45. And I got 7. So just for this part that I plugged in the calculator, I got 7.07. Well, and I dropped down the minus 1. So what should that be? 7.07 minus 1 is just going to be 6.07 is equal to x. So again, all that really did, the plus 1, we just added an extra step, right? I had to do minus 1 to both sides. But you always kind of want to do this little first section, right? Multiply like we've been doing in the past. Whatever number, if you had to do plus 1, then you would have done plus 1 at the end. Anything like that. All right, last example here. Howard is designing a chair swing, right? The swing ropes are 5 meters long. So here's the swing, right? It goes back and forth. The actual rope is 5 meters. You see they're long. And in full swing, they tilt at an angle of 29. So there's our angle right there. Howard wants the chairs to be 2.75 meters above the ground. So again, you want that little extra space so your feet aren't touching the ground, of course, right? You want that hovering pretty high there. So how tall should the pole of the swing be? Well, if I create that right triangle that we see here, right? And we work with the little triangle, my only issue is that when I figure this out, I'm only going to be able to figure out that piece right there. And I know it's kind of hard to see. Let me use a different color and see if blue pops up here. So I'm only going to be able to find that height. And then at the very end, I'm going to have to also include this additional height of the 2.75. Okay. So again, it was kind of like that, the kite problem we had last week where you had to add the extra 10 meters. Same idea here. We're going to find out this height first of the pole and then add an additional 2.75 meters. All right, so let's go ahead and set this up. All right, there's my reference angle. Cross, that was my opposite. Cross from the 90 degrees, that's my hypotenuse. And then the last one here is my adjacent. And again, that's the one I'm trying to find, right? I'm trying to find that height right there. So, if I'm trying to find my adjacent, and they give me my hypotenuse, which is that going to be? What has adjacent hypotenuse? That is going to be cosine theta. It's adjacent over hypotenuse. All right, guys, so I'm going to pause the problem here, show my work, and then I'll resume here in a second. All right, guys, so I went through all the work, right, and I got 4.37. Now, again, go back here. All that's saying 4.37 was only the height of the adjacent piece, so only this little section here. So what do I have to do? I also have to include that additional height that he wanted, so again, your feet don't track. So what's 4.37 plus an additional 2.75 meters? That gives us 7.12 meters tall. Again, that's how tall that pole should actually be, so your legs aren't aren't hitting the ground. All right, guys, here is your class activity. So again, once you guys finish, check your work with my sub. He has the answer key. If everything's perfect, turn it in the inbox. Have a nice day, guys. I will see you guys tomorrow.